Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Hi, everybody. Couple of things before I do the review for quiz two. Quiz two, I like those special effects. Quiz two. And that is, first of all, I found out I'll be teaching this summer Chem 1211. So if you know anybody who needs it, I'll be teaching it same way I'm teaching it now, except it will be in the summer 8 weeks instead of 16 weeks. All right. Now, as I mentioned in the video for the answers for quiz one, last semester, the chairman of the chemistry department issued some rules that we all have to follow, we being the faculty. And one of the rules is I no longer can put important information at the back of quizzes and tests. For a number of years, I've been doing that. Before that, when I taught 1211, I didn't. And I decided, let me do that. And now I can. So for the videos, when you watch the videos, those are from when I could do that. So if it says you don't have to memorize it, it'll be important information, no more. You do have to. So look at the important information. For this one, there's just the formulas you have to know for the temperature conversion. Well, you have to know other stuff too, but that would have been given to you. It won't be. All right. Now, just to remind you, this Thursday, the 20th of February at 8 a.m., probably earlier, I will email you the password for quiz 2 PDF file. You'll have until Friday, 8 p.m. to take quiz 2 and upload your answers as a single PDF file. I reserve the right to subtract up to 25 points. Anyone who doesn't follow instructions or anyone who doesn't upload, it should be just quiz 2 on time. I used to give the two together. I've separated them. I'll have to fix that. All right. Quiz 2 has actually it's 4 pages because the 5th page with important information is no longer there. I'll change that too. It has 18 problems, including 6 multiple choice, and it's worth 50 points. It covers chapters 3 and 4, along with temperature conversions. And who's ever transcribing it, hopefully you can get all my words correctly. All right. As I mentioned earlier, I won't have important information. This YouTube talks about that. And as you know, we're having our meeting tonight. Now, if you go to the lecture section of Blackboard, you'll see Chem 1211 quizzes 1 and 2 review. Well, the first part of this dealt with quiz 1. Second part, like I said, I used to do both of them together at the same time because we were told we couldn't give tests online. Students had to show up at Glen Ellen. So that's when I started giving quizzes. All right, let's go through things you should know. Hint, things you should know. Did you get the hint? Don't you like it when I'm subtle? Well, anyways, first of all, what is matter? Matter is anything that has mass and occupies space. All right, now when we talk about matter, there are 3 physical states of matter you should know. Here's a secret about Dr. White. When I do something in red, my favorite color, that means it's really important. And you should know that a solid has definite shape and definite volume. A liquid has indefinite shape, but definite volume. And finally, a gas has indefinite shape and definite volume. So if I had a solid like this, one of my favorite eye candy toys. And it has definite shape and definite volume. Now, if you look in this bottle, I have some water and it has indefinite shape. That means if I poured it into another container, it would take the shape of the container, but the volume that we can measure would not change. Now, finally, with a gas, and all around us is air, which is a gas, has indefinite shape and definite volume. And you should know the three states of matter and their definitions. All right, now when we talk about substances, there's two types, element and a compound. Now the elements you've learned from the periodic table, and compounds we'll learn throughout the semester. Example, gold is an element, but water is a compound, also sometimes called a molecule. Now, when we talk about substances, you can have a pure substance or you could have a mixture. And you should know how to identify a sample as one of the above types of substance or mixture. Now, an element cannot be broken down to smaller things by a chemical change. An element cannot be broken down to smaller pieces by a chemical change. Hopefully you can all read my printing. Now, a compound can be broken down. So if I take water, I can break it down to smaller things by a chemical change. Now, a mixture are two or more substances that are together, but each retains its own identity. A mixture are two or things brought together and each retain their own identity. I can dissolve salt, sodium chloride, in water. If I evaporate all the water, I get back the sodium chloride. And we used to do an experiment like that, but with potassium chloride in the lab in 1211. Now, when we talk about substances, there are two different types of properties, physical property and chemical property. Now, physical property tells how it changes state, like water freezes at 0 degrees C. A chemical property describes how it will or can undergo chemical change. An example of that would be gasoline is very flammable. Water is not flammable. That's a chemical property. And you should know examples of each. Well, I just gave it to you. Next, physical change and chemical change. A physical change is when a substance undergoes a change in state. It doesn't change its composition. Therefore, water melting from a solid to a liquid is a physical change. Water boiling, going from a liquid to a gas, is a physical change. Now, chemical change is when a substance changes its chemical identity. Example would be, which you don't want to see, but it is, if you have a car and you start seeing rust, and rust is iron undergoing a chemical change from iron to ferric oxide. Ferric oxide is the chemical name for rust. Another place chemical changes happen, now Dr. White's going to get very personal, is in your stomach. When you eat food, your stomach and your intestine break it down by chemical changes. And if you were to take Chem 1212, which I haven't taught for a while at COD, or Chem 170, which I do teach at Elgin Community College, which is one semester organic, that I teach about the different things in the chemical reactions, how carbohydrates, fats, and oils, and proteins undergo chemical change in your stomach. All right, next, you need to know how to convert from various scales. Now, K is for Kelvin. Degrees C, sometimes written this way, is Celsius or centigrade, the old name. And F, or degree F, is Fahrenheit. Now, remember, these are formulas, definitions. The number 273 is an exact number. The number 1.8 and 32 is an exact number. Now, I will only ask you to go from one to the other using this formula, which is real life. Some students or teachers will say, well, if you have so many degrees F, what's it in Kelvin? Well, first you have to convert the Fahrenheit to Kelvin, centigrade, C, and C to Kelvin. I don't do that. Now, let's take a look at these, one of these. Let's pretend it's warm outside. Real warm. By the way, right now, I think it's about 7 above Fahrenheit. All right, let's take a look at this. This is a word problem. Take a deep breath, relax. If you've watched my videos, don't forget to do the practice problems. You know how to do word problems. The first thing is, what are you being asked to find? And the answer is, what is the temperature in degrees C? Now, I don't know where I started doing this in college, I think. Put a question mark. You don't have to do this, degrees C. What am I given? Well, you're given the temperature in Fahrenheit. Oops. Now, this is some formula you have to memorize. Degrees C equals degrees F minus 32 divided by 1.8. Now, it helps to show your work. If you press the wrong buttons on your calculator and put down the wrong answer and don't show your work like I'm doing, you get 0 points. If you show the work, say this were a 5-point or 6-point question, and you made a mistake but show your work, I'll take off only 1 point for a math error. So it always pays to show your work. So we have this formula, and now we know degrees C And what's degrees F? Well, we figured that out by reading the problem, so I'll put it in here. Now, with this formula, it's important to do what's in the bracket first and then the division. In this formula, you do the subtraction first and then the division. So I'll do 83.0 minus 32 or 32. I get 51. Divide that by 1.8. And my calculator gives me this answer. Oops. Now, you can leave things in scientific notation. Now, in my test quiz 2, underneath your name, like quiz 1, will say, please use proper significant figures for all calculated answers. Well, what do? Well, we look at this and say, this is a division. The 32 and the 1.8 are exact numbers. And the only number that we use to determine the significant figures is this, 83.0. And that's 3 significant figures. So we now have to round off our answer to 3 significant figures. If not, I'll take off a point. Keep this first number 1. This is significant 2. This is significant number 3. The next number you use to round off. And that's the 3. Is that 4 or higher, lower? Let's say that again. Is that 4 or lower or 5 or higher? And hopefully all got 4 or less. So that means I drop this, this, this. And the correct answer here is 2.83 times 10 to the first. And if you want to put the units degrees C. And you could also write it the other way, 28.3 degrees C in decimal form. But that's 3 significant figures. In the calc formulation for converting from one temperature to the other, the temperature you start with indicates how many significant figures you get, because the other numbers in the formula are exact numbers and do not play a role in determining the temperature, the significant figures. All right, let's do one more. And hopefully you all know by now, H2O is water. And say this for 5 points. If the temperature of a beaker of water is 21.3 degrees C, then what is its temperature in degrees F? So we have this word problem. The first thing you should do is, what are you being asked to find? And I like to put a question mark, and that's degrees F. What are you given? 21.3 degrees C. So we're going from degrees C to Celsius to Fahrenheit. And if you look at the review, we're going from degrees C to Fahrenheit. Degrees F equal 1.8 times degrees C plus 32. And you have to memorize this. Remember, I showed you in a previous video, write these down and say them 5 times, and that will help you memorize them. It's better than flashcards. So we now know the formula that you have memorized, degrees F equals 1.8 degrees C plus 32. So you have, now we know what degrees C is right here. So this is equal to 1.8 times 21.3 degrees C plus 32. And now I'll pick up my trusty calculator, clear it. You do the multiplication first, 1.8 times 21.3. I get a number. Then I add to that plus 32. And my calculator gives me this number. Now, the only number that you use to determine significant figures is this one, 3 significant figures. This is an exact number. This is an exact number. And exact numbers do not play a role in determining significant figures of your answer. And on quiz 3, test 1 and 2, and quiz 4, 5, and 6, they'll say on your name, please use proper significant figures for all calculated answers. So now we have to round this number off to 3 significant figures. Keep the 7, keep the 0, keep the 3. And the number to use to round off is 4. Is that 4 or less or 5 or higher? And it's 4 or less, obviously. And therefore, I drop this. And the correct answer using significant figures or if you want to write it in decimal, and that's how you do the conversions. And the last one, Kelvin centigrade, that's just adding 273. And this is stuff you should know how to do, and you have to memorize these formulas. The best way to memorize it, and I'll give you an example, is to write it down 5 times and say it. Degrees F equal 1.8 times degrees C plus 32. Say it again, degrees F equals 1.8 times degrees C plus 32. And you do it 3 more times. Another day you do the same thing. It will be in your brain. Oops. All right, let's talk about chapter 4. All right, we're getting into some chemistry now. Dr. White's getting all excited. First thing you should know is the atom. What is the atom? And you should know the atom is the smallest particle of an element that retains the characteristics, all the characteristics of that element. My ring is made out of gold. It's older ring, so it's expensive, real gold. And if I were to take one atom of gold, an element, that would have all the characteristics of any other goal you have. Now, what makes up the atom? And you should know, you should know, hold on, I'm going to be super subtle. Don't you love how subtle I can be? You should know the three subatomic particles, those are the particles that make up the atom, are the electron. And the electron is a subatomic particle that has a negative charge. The protons. The protons are subatomic particles that possess a positive charge. And finally, the neutrons are subatomic particles that have no charge associated with them. How many of you have ever seen the TV program? I haven't seen in a while, cartoon Jimmy Neutron. If they'd asked me, I would have called them Jimmy Electron. They're more exciting than neutrons. But then again, they didn't ask me. All right, let's go through this again. You should know the three subatomic particles. Electron. An electron has a negative charge. Proton. Proton has a positive charge. And neutrons have no charge. Now, an important experiment was done by Thomson in England about 1900, 1910, well, over 100 years ago, wow. And that's the cathode ray experiment. And there, Thomson found electrons have a negative charge. And that also helped develop the old television tubes. All right, next we talk about the nucleus of the atom. And you should know that that's the center of the atom. Now, important thing that elucidated, Dr. White used a fancy word. Elucidated means figured out, and that's Rutherford's gold foil. And Rutherford's gold foil experiments I talked about it in the video, was that he found out that the dense nucleus, center of the atom, contains only protons and neutrons. And later they found out, we'll talk about it in the later chapters, the electrons are around the nucleus. So you should know Rutherford's gold foil experiments help elucidate the nucleus, figured out that it's dense and it contains protons and neutrons. By the way, how many of you have ever heard of a Geiger counter? And when he was doing this experiments, one of his grad students was named Geiger, who came up with the Geiger counter, which is used to find radioactive material. All right, now, we've already done this, but the number of protons, the atomic number, tells you the number of protons in the nucleus or in the atom. Since all atoms of elements have a net zero charge, the atomic number equals the number of protons equals the number of electrons. Now, when we talk about elements which make up the atoms that make up other things we'll talk about this semester, they're different groups from the periodic table. And I'll show you the periodic table in a second. You should know which column is the alkali metal. You should know which column is the alkaline earth metals, which column are the halogens, and which are the noble gases. Till about 1965, 66, that's not too long ago in my life, They were called inert gases until some very creative chemists found a way to make them react, and they were no longer inert, so they changed the name to noble gases. Sorry about that, thought I had it open. All right, let's look at the periodic table. All the way to my left, underneath the column with the red number 1, not including hydrogen, not including hydrogen, are the alkali metals. Lithium, sodium, potassium are the key ones. I've never worked with rubidium, cesium, or francium. If I haven't, you haven't, and you never will. Yes, Dr. White's worked with lithium metal, sodium, and potassium. Potassium's really dangerous to work with. Sodium, you got to be careful. Lithium, yeah, a little. But you should know these 3 are the alkali metals. The second column is the alkaline earth metals, and you should know examples of that. And the only 2 I asked you to really learn that you'll have in your life is magnesium and calcium. Now, SR strontium is good to throw into fires, strontium salts to make it turn red. But did I tell you all good organic chemists were pyromaniacs when they were little? We loved to burn things. All right, now let's go all the way over to the right, second last column, underneath the letter number 7. Those are the halogens. Fluorine, chlorine, bromine, iodine are the ones you should know. And if I ask, give an example of a halogen, well, my favorite, I worked a lot with fluorine and bromine, iodine too. Not that much fluorine. It's dangerous stuff in certain molecules. And finally, the very last column, underneath the letter number 8, are the noble gases: helium, neon, argon, krypton, xenon, and so on. And if I were to ask, give an example of a noble gas, well, you could put down argon. Dr. White works with a lot of argon in grad school when I got my PhD, or krypton, which I've never worked on with. By the way, in our universe, krypton is a colorless gas, not a green solid that kills Superman. If you know your Superman stuff. Now, when we talk about substances, there are various names we give things. And one important name I think you should know is a metal. Now, metal is an element that has certain characteristic properties. One is luster. Luster means you can shine it up, make it very shiny. My gold ring, if I shined it up, polished it, would be very shiny. When I was young, like about 8 or 9 by then, till I got to college, one of my jobs for my mother was when we'd have people come over for important dinner, I had to polish all the silverware. I hated it, but that was my job. Now, another property of a metal is thermal conductivity. It conducts heat. And if you go into your kitchen and look at your pots and pans, I would bet they're all metal. Another example of a characteristic of a metal is electrical conductivity. That means it conducts electricity. In your house, your wires are made of copper. They used to use aluminum back in the 40s, but those caused fires. And those have been outlawed in the United States, I think the rest of the world. And finally, a new word to learn, malleability. That means you can pound it and make it real thin. How many of you have ever seen gold leaf? That's very thin gold foil. And some examples you should know by chemical symbol and name: aluminum, Al, copper, iron, Fe, silver, Ag, gold, Au, lead, Pb, tin, Sn, and zinc, Zn. And those are all metals. And with that, I'm done. I'll stick around if anybody has any questions, but don't forget, the best way to study for my quizzes, and test one is coming up eventually, and that's a lot to memorize. I'll put out an announcement after quiz 2 about that, is to watch the videos and then do the practice problems. If you need any help, come to my office hour. If you're unable to come to my office hour because maybe you work, reach out to me by email and I can set up a special Zoom meeting with you if you need that kind of help. Also, always feel free to email me with questions. So with that, I'm done. I'll stick around for a little while, but I'm going to do my favorite ending, and that's Gehen gesund, which is Yiddish, go in health. And then from the Beverly Hillbillies and Granny, look it up on YouTube. I'll steal how she would say goodbye at the end of that TV show. I'd say, bye, bye. So that from Granny, bye now.